Mr. Kiran.
Sir, shall I start, sir? HOD, sir, shall I start?
Yes, sir. Please, sir.
Yes. Yeah. Respected convener of this faculty development program and head of the department of CSC, Dr. P. Kiran Garu, and today's resource persons, my dear participants from various colleges, and my dear colleagues. A warm good afternoon to one and all. On this great afternoon, I welcome you all to the last day of 1 week national level faculty development program on societal applications of machine learning. So first of all, I'd like to convey a hearty welcome to today's resource person, Dr. Seema Sharma. Good afternoon, madam.
Good afternoon, sir.
Ma'am, first of all, from the Department of CSC, Sri Vishnu Engineering College for Women, we'd like to convey our thanks to you, ma'am. Despite of your busy schedule, you joined with us to share your valuable knowledge. So before entering into the session, let me take the privilege to introduce you, ma'am.
Thank you.
It is my great honor to introduce Dr. Seema Sharma. Dr. Seema Sharma is currently working as Associate Professor.
Sunil sir, can we move the slide and then proceed, sir, please?
Yes, sir. Yes, sir. Dr. Seema Sharma is currently working as Associate Professor in the Faculty of Computer Applications, Manav Rachna International Institute of Research and Studies, Faridabad. She is engaged in teaching MCA and BCA classes and has teaching experience of more than 14 years. She has published more than 20 research papers in national and international journals. She has guided various students of MCA students for their project works. Her main interest areas include software testing, generic algorithms, Java, and mathematics. Ma'am, really, we are glad to have such a great person as a resource person to this faculty development program, ma'am. Ma'am, now I request you to enlighten our participants by covering a topic on regression analysis in machine learning. The platform is yours, ma'am.
Thank you very much, sir. Very good afternoon to one and all present here. First of all, I would like to thank Dr. Kiran Sri sir, who has given me this opportunity to speak the lines in this FDP. So it's really my pleasure to be here online. So without any further delay, I just want to start this FDP that would be on machine learning and the regression analysis. And I will also tell you how we can apply this regression analysis in the crop yield prediction. So I'm sharing my slides. Is it visible?
Yes, ma'am.
Yes, ma'am. Visible. You can go for a full slide mode.
Okay. Thank you, sir. So the topic of this FDP is regression analysis and the crop yield prediction. So in this FDP, I would like to overview some concepts of machine learning. Also, I will tell you that how the machine learning algorithm that will be different from the other algorithm, the types of the machine learning algorithm, to understand the linear regression and the types of the problem that it can be used for. And also I will tell you how we can apply the machine learning in order to predict the crop yield. So the first thing that in our mind is, what is actually a machine learning? Machine learning encompasses a lots of things. The field is very vast and expanding rapidly. And in today's era in which we are living right now, this is nothing but it is an age of data. And we have a massive amount of data, which is increasing day by day. Now, since the data that has been increasing day by day, we need some better computational power. We need some more storage resources. And this is nothing but it is a real challenge to make the sense of all the data. There are so many companies that are busy in building the intelligence system by using the concept, by using the methodology of data science, by using the methodology of data mining and machine learning. So we can say that this machine learning is nothing but it is a buzzword today that involves so many algorithms. And these algorithms, nothing, it will provide the sense to the data. It provides the sense to the data in the same manner in which the human that can do. And this machine learning, this is the, we can say it is a branch of the artificial intelligence, and that will extract the pattern from the raw data and by using the well-defined algorithm, or we can say it allow the computer to learn from the past experience without the human intervention. So the outcome that we want from our computer algorithm, that is prediction. If we want to predict something, then we apply the machine learning. So when we are talking about the machine learning, three things that comes in our mind. First one is the task. Second one is the experience. And third one is the performance. Task means what we have to do. What is a real world problem that we want to solve? For example, suppose we want to predict the sale of the product. We want to classify whether the email is spam or not. So this is task. Experience is knowledge that we gain from the data that is provided to the algorithm. We provide the algorithm, we provide the data to the algorithm for the training data, for train the system, for train the model. So once the data that is provided, the model run iteratively to learn some inherent pattern. So like human, machine now can learn from the experience by analyzing the situation, by analyzing the relationship, etc. And performance that will indicate how well the particular machine learning algorithm has performed the given task by using the experience. And this performance that can be analyzed, which will be based on the well-defined matrices like accuracy. You can evaluate the F1 score, evaluate the confusion matrix, evaluate the precision, evaluate the recall, sensitivity, etc. So this is what the machine learning. Suppose we want to evaluate, will my friend will be willing to play the tennis today? Because the weather forecasting is likely cloudy, but not with the wind. So we cannot judge. We cannot predict. We can predict by using the past experience. We cannot predict actually whether he will play the tennis or not. So what we have to do, we have to check what minds in a too hot, whether it want to play in a, never play on that day, or it may play in the cloudy situation, it may play in the wingless days. So depending upon the past experience, we can evaluate whether my friend that will be play the tennis today or not. So when we are talking about that machine learning algorithm, first that we have to develop the generic algorithm. That means one that is not the custom code for the problem. And in the most type of the machine learning, we have to train the algorithm with some known data set. We have to provide some data set so that the machine learning model that can be trained. And by using that trained machine learning algorithm, we evaluate. We can evaluate the values of the new data. So instead of writing many custom program, first of all, we have to write the generic machine learning program.
Excuse me, madam.
So yes.
It is moving.
Ma'am, are you in first slide, ma'am?
No, I'm at the third slide.
Actually, we are able to see only the first slide, ma'am. We are in design mode, ma'am. Slide.
Okay.
Can you share the presentation?
Is it visible now?
Visible, but it is in design, ma'am.
It is
not
in
presentation.
Okay. I will share again. There may be some problem. I will share again.
It's better to share the entire screen, ma'am. I hope.
Okay, wait.
Yes, ma'am.
Now, is it visible?
And now
Yes,
it is
ma'am.
visible,
Now-
ma'am. Yes, it is visible.
Okay.
Now it is working, ma'am.
Okay. Now I will take another example. There is a city and it had an active traffic camera at this location, and what the camera that will do, it will create the images, and this images that will be uploaded to the web every 2 minutes. So if this information could be put into the format that is usable by an algorithm, and the algorithm is then trained with the past hourly traffic pattern. And if it has successfully learned, it will be able to predict the future hour traffic patterns. Now there are two distinct types of machine learning. First one is the supervised machine learning, and the algorithm is trained on the predefined set of the example, which allow the algorithm in order to predict the prediction for the new data set. So the supervised machine learning, as this name indicates, it consists of a supervisor. Supervisor means teacher. Such type of machine learning apply the algorithm from the past experience to the new data by using the labeled example. Now suppose we have provide the input, let it be X, and we have provide the output, let it be Y. There is a mapping between the function. Let's suppose that mapping is Y is equal to Fx, the relationship between X and Y. Now, by using this mapping function, they can be used in order to predict the output for any new input after learning from the existing data. This is what the supervised machine learning. Okay, so once we can predict the data, what we have to check whether that prediction that will be accurate or not. And this accuracy that can be evaluated by comparing the predicted value with the actual value. Okay, in order to find the error, we have to compare the predicted output with the actual output, and we can modify the model accordingly. So when we are talking about the machine learning algorithm, so classification and regression is one of the algorithm that can be applied for the supervised machine learning. For example, suppose we have to check whether the email is a spam or not. This is the one of the example of the classification. And when we are talking about, there are so many more classification algorithms are also available. For example, support vector machine, k nearest neighbor, naive Bayes, discriminant analysis, and decision tree, etc. And when we are talking about the unsupervised machine learning, that means we have given a bunch of unlabeled data. Unlabeled data means what? That the machine does not have any information, does not have any guidelines. It will just classify, or it will group based on the similarity, or we can say the based on the pattern. For example, suppose I have given the images of mango, I have given the images of orange. Initially, the machine has no idea about how the mango looks like, how the orange look like. So based on the similarity, based on the pattern of the mango and the orange, what it will do, it will classify, it will make the cluster of the orange, and it will make the cluster of the, mango. But in real world, it will only segregate it, but it cannot tell that the real world that it is a orange, it is a mango, that we have to take the name, what this cluster will be, what this cluster will be. Okay. So this is unsupervised, and clustering is one of the most common example of the unsupervised machine learning. So this is machine learning, supervised and machines, unsupervised, linear regression and pattern recognition, that is classification, clustering, that is used in the unsupervised machine learning. Classification that will be used in order to predict the discrete outcomes. It is used for the discrete outcomes. But when we are talking about the regression analysis, it will predict the predict the output in a continuous form. Now we will take the another example, that is oncology, Watson oncology. this is nowadays we see that there are so many people, they are, having a problem of the cancer, or whether the tumor that is existing is cancerous or not, that the research is still going. And this research is at the rate of approximately 800 academic paper day by day, they are publishing. Too many for even of the best of the physician to stay abreast of. Watson has trained with over 15 million pages of the medical content that include 200 medical textbooks, and they are continuously being fed the information as it being available. So by using that, the material that will be the information that it has to be fed on, and we can also check that the whether the suspected tumor is a cancerous or not. Now take another example of the machine learning. These are the images of the handwritten numbers. When the handwritten numbers that have been applied to the machine learning algorithm, it will generate that this number is 1, this number is 2, this number is 3. So this is the pattern recognition, classification. Train the algorithm in order to read a zip code. Another example of the machine learning, the emails. Apply the machine learning algorithm to the emails. We easily identify that this is spam and this is not spam. This is the example of the pattern recognition that will classify the email messages. Self-driving car, these are also an example of machine learning. Classroom of the future. Now, we can say that the e-student that will be access to the course of their education, help the students master the skills critically to the meeting of their goals. And by using this sophisticated analysis and that the data that have been stored in the cloud, that we help the teachers to predict the students who are at the most risk, their roadblocks. They can suggest a measure to help the students overcome their challenges. This is another example of the machine learning. Now we will come to the regression analysis. Regression analysis that can be, viewed as a type of the supervised machine learning. Regression analysis is nothing but it is the statistical method tool that allow the user to study the relationship between the dependent, that is the target value, and one or more independent, that is called the predictor variables. And it helps the analyst to understand how the value of the dependent variable changes with respect to the independent variable. The value of the predicted are usually the continuous. We can say the real, like temperature, age, salary, price, etc. For example, suppose a company want to analyze its data in order to find the extent to which the expenditure on the advertisement increase the sale of the particular product. Similarly, we can use the regression analysis to predict the rainfall by using temperature and the other factors. We can use the regression analysis in order to determine the market trends, use the regression analysis to predict the road accidents due to the rash driving. So this regression analysis is widely used for the prediction. We can forecast, we can model time series the data and infer the causal effect relationship between the variables. Now we come to the linear regression. Linear regression means we can predict the continuous quantity. Suppose we want to, as I have already told you, the cost of the item, the temperature, the force that will be acting on an object. So these are the contrasts to the classification, which predict the discrete quantity. So in linear regression, we are assuming that underlying the behavior is linear. That means we have only one variable. When we have a one variable, then we get the straight line. Okay. So now the question arises, what does depend linearly means? So we use linearity all the time without realizing it. For example, suppose we want to bake some cookies and the recipe calls that we need 2 cups of flour. in order to bake some cookies. Suppose we want to double the recipe. So we need 4 cups of flour. We want to triple the recipe. We need 6 cups of flour. Okay. Another example, suppose I want to take 1 Starbucks brand coffee, which is $2.1210, dollar. And suppose my friend is also buy one too. So its cost that would be double, that is 4.20. So the cost depends linearly on the number of the cups that we have purchased. So this is what is dependent linearly mean. So we have, when we are plotting some linear function on the graph, it will come a straight line. So these are the straight line. That means this is a linearly. Now the linear function have a constant rate of change, and we can see it graphically. For example, suppose I have taken 1, 1.1, 2, 2, 3, 2.5, 4, 3. These are the data. That in these data, x changes by 1 and y changes by 0.5 in this case. So this is a linear graph. A line which is uniquely determined by the 2 points, and we write the equation of the line as yx is equal to mx plus b, where b is the y-intercept. Okay, m is the slope, and x is a data, is a variable, and y depends linearly on x. Now, since the power of x is 1, so this is the equation of a line. But when we are taking, suppose the power is 2, this is not linearly, y is not linearly dependent on x because the power of x is in 2. Okay, so this is the equation of the parabola. Suppose, take an example, assume that we are going to the shopping and there is a 25% off on the original price scale. The amount of the saving that can be represented by saving is equal to 1/4 of the original price. So in that case, let's suppose the original price is x. So y is equal to x upon 4. In this case, b is 0. That means y-intercept is 0 in that case. Now suppose I have taken 3/4 into the original price. So in that case, suppose the original price is x. So in that case, again, the y-intercept is 0. Now take the another example. Suppose I have taken, in that case, y-intercept is not 0. Yx is equal to 1 plus 4x. In this case, the y-intercept is, let's suppose, 1. Okay. Now, when we are changing x by some amount, let's suppose the y changes by del. So in that case, apply x plus del x minus yx. That means when we apply some changes, that equation with our equation, and this is equal to 4x. That means y changes. How much does the y change? So in that case, again, apply x plus del x minus the function, original function. So it comes 2 del x. That means if y changes by 2 times the change in the x. The slope determines the factor in front of the change. So these are the example. Let's take another example using linear regression for the science experiment. There are so many things where the linear regression that can be applied. There are so many applications where the linear regression that can be used, in which the science is the one of the area where the linear regression that can be applied. For example, suppose we have assumed that the weight is 2 kilograms. And when we apply, like the weight of the object is 2 kilograms. When we are applying Newton's second law of motion, that is force. So force acting on the body is given by mass into the acceleration. F is equal to ma. But the weight is fixed, then the force is linearly dependent on the acceleration. That means if we plot the acceleration on the x-axis and the force on the y-axis, we get the straight line. And again, in this case, y-intercept is 0 because we have no acceleration, we have no force. Okay, it is linearly dependent on the acceleration. So as I have already told you that let's suppose the weight of the object is 2 kilograms. So F is equal to 2a. And suppose we are taking by taking the measurement and apply some measured force, we get, if the acceleration is 1, so the measured force is 2.1 and the actual force is 2. Measured force is 4.9 and the actual force is 6. And when we are applying this on the graph by taking the points 1, 2.1, 3, 4.1, so we get, apply y is equal to mx plus b, and we got the points that the value of m is 1.4 and the value of, b is 0.7. We got the final equation y is equal to 1.4x plus 0.7. So in that case, when the y, this is what? Nothing but y is equal to 2x. Okay, so when we plot a line, it will passes to these two experimental data points. Now take the another example. Here we have taken the 2 points. Now I have taken the 4 points in that case, 1, 3, 5, and 8, and able to apply the formula, which is F is equal to 2A, measured force and the force predicted by the formula F is equal to 2A. So suppose we have given some points when we have applied, plot these points on the graph. So the graph that will be look like this. Now what we have to do, I have to pass the line that will be best fit by using these points. Okay. So these are the lines that can be plotted. So we have to find out which line is best, linear approximation of the data. It depends on what do you mean by the best, or it will minimize by the following errors. Okay, so these are the errors. These are the points. If it will be on the line, like if this point is on the line, the small portion, we can say the small gap between the y distances, these are nothing but it is the error. So what we have to do, we have to find a best fit line that will be passed through these lines. This is the least square method and nothing but it is a linear regression, or we can say the least square fit data. Next one is the linear regression that will be used in many areas that I have already told you. I have taken the one of the example in order to predict housing prices. Suppose there is a girl, Karen, which is a real estate broker, and she feels that she can walk through a home in Leon County and pretty good idea what a fair listing price is. Now, suppose she hire a trainee who does not have her experience, and she wants to devise a strategy to help him to learn accurately price single family home. So what she can do? So the Karen decided to write some information, and she feels which is important for the each house and is sold in the last year. So she makes a table like if the yard is 2,900 square feet, 4 bedrooms, 4 bath, no pool, 3 garage, 1 acre lot size, neighborhood, and the listing price is 589,000. So this is the idea that her trainee that will look this data and predict a listing value for the 3 bedroom, 2.5 bath, 285 square feet house in the Baton Hills with a pool and 2 garages. So machine learning would use the Karen's table of the information about the houses at the training data set for the generic algorithm, and it will predict the listing price of the house. So of course, this prediction lies heavily on the quality of the training data set and the choice of the criteria that we will use in the training data set. So by using this training data set, it will be predicted. This is the predicted outcome. Now, when we are talking about the regression analysis, the first thing that will come in our mind, what are the types of the linear regression? What are the type of the regression analysis? The first regression analysis that we have already done, that is the linear regression. As I have already told you, linear regression means what? That there is only one one dependent variable. Now, the second thing that is come in our mind, the second one is the polynomial regression analysis. In a polynomial regression analysis, it is nothing but it is also a linear. This is also a form of the linear regression, but in that case, the relationship is between the dependent variable. Independent variable is x and the dependent variable y, and it is molded as an nth degree polynomial. That means that the polynomial regression, it will fix a non-linear relationship between x and the corresponding conditional means of y. So the relationship that must be in a polynomial terms. In case of plotting the scatter plot of the curve data, it produces a patches of many positive residuals in the middle, and all the independent variables are actually not independent. Okay, so we need to understand the polynomial regression in that can be clearly understood as we can apply it on the linear data set, generates the good result, but the same model when applied on the non-linear data set, that will produce the erroneous result. Now we come to the second type of the regression analysis. Second is the third one is the regularized regression. In the regularized regression algorithm, can result in overfitting the model on the trained data set, and such model will not generalize well on the unseen data. So therefore, we have to overcome the limitation. So this limitation that can be overcome by the regularization of the regularization regression analysis. It will, panelize the large coefficient. And there are two types of the regression in that case, lasso and ridge regression, that will implement the regularization of the regularization regression. And last one is the logistic regression. That will belong to the linear classifier, and it is somehow similar to the polynomial and the linear regression. Very simple and very easy to understand the regression technique. It is primarily used for the binary classification, though it can be applied to the multiple classes. To understand the logistic regression, we must understand the sigmoid function, because the sigmoid function is used in the logistic regression and the natural regression algorithm. Now we come to the using logistic regression to predict the crop yield. Now we know that the agriculture is one of the crucial occupation that serve the society, both in terms of the living and employment. And because of the extensive increase in the population or busy daily routine of the individual, the status of the nutrition in human being is deteriorating day by day, and it needs to be improved. There are many factors that can influence the crop yield and the risk that are involved with the farming. Actually, if I want to categorize, the factor that will influence the crop yield, some of the factors are soil fertility, availability of the water, what will be the situation of the climate, what are the disease, or we can say the quality of the pesticides. So the crop prediction is one of the serious issues that will be faced by the farmer. And because of the lack of the knowledge about the harvest glut, about the weather uncertainty, seasonal rainfall policies, depletion of the soil, availability of the fertilizer, cost, pest control, other factors, that leads to decrease in the production of the crops. So these are the major challenges that are faced by the farmer. And when we are talking about the modern agriculture, lots of research that have been, in some of the new innovation that has to be approached, that helps not only to increase the efficiency, but it will also reduce the loss of the natural resources. So this technology, this plays a very vital role in the farm industry for improving the agribusiness. And the researchers have to manage the grow crops in the desert, in other areas where the unfavorable, conditions occur. So with the advent of the generic engineering, it is not possible to create the crop to improve the insects and pest resistance, herbicides, or drought tolerance and disease resistance. It gives the farmer an additional tool to increase the much artificial intelligence, or we can say the machine learning, on the agriculture that will give a rise to a wider variety of the data and analytics tools. These data that are to be collected by, different type of sensor allow a better understanding of the environment and the better, agriculture operations. And logistic regression analysis that has to be applied by the machine learning. And this, the logistic regression that will play a very vital role. We will predict what is the yield of the production. So they, depending upon the factor that influence the crop yield, or we can say the fertility of the soil, availability of the water, climate conditions. So on the basis of the characteristics of the factor, it can be classified into 4 groups. First one is the physical factor, institutional factor, infrastructure factor, and the technology. Power, roads, garages, marketing, insurance and storage facilities, what are the chemical fertilizer that have been used, insecticides, farm machinery. So these are the, factors that mainly influence the crop yield. And every crop has to meet all the factors in a suitable condition for increasing the rate of the production. For example, suppose if I want to cultivate the rice, then the optimum temperature that needs to be 21 degrees Celsius to 37 degrees Celsius. Also, I have to check the soil pH value that should be in between 6.5 to 7.5. And if it is greater than 7.5, then the soil is alkaline. If it is less than 7.5, then the soil is acidic in nature. So in both the cases, the rice yield is impossible to cultivate. So all mentioned factors that should be considered carefully during the planning stage of the, farming. So we have applied the logistic regression in that case. In the logistic regression, it is the S-shaped curve. And the function that have been used to evaluate is a sigmoid function. Sigmoid function, as we all know, that it is fx is equal to 1 plus e raised to power minus x. The center one is the, threshold line. The value of the threshold line is 0.5. And the observation is that if it is classified more than, if the predicted value is above 0.5, more than 0.5, then the observation is classified as 1. That means yes. And if it is less than 0.5, then it will be classified no. That means the value of the 0. And if the value is nearby 0.75, then we can say that there are 75% chances that the target value that should be 1. That means it is true. So this is what the logistic regression is. So the factor that I have taken is ratio of the nitrogen, and that is P, ratio of the phosphorus content, K, ratio of the potassium, temperature that have to take, humidity, that means relative humidity in the percentage form, and the soil pH value and the rainfall in mm. So this is the proposed system. So what we have to do, I have to input some data set, evaluate the feature extraction, train the data set, train the model, find the RMS output accuracy, and that data, that trained data, that will be used in order to find the prediction of the test data, evaluate the test data, and this is the final model. This is the algorithm that have been used in order to evaluate the prediction, whether the data that has been good or not. So sigmoid function that has been used, and this is the result. That means the logistic regression accuracy is 95%. So I have taken the precision, I have calculated the recall, F1 score, support is nothing but the sample that have been for that one. 1 that means 0 indicates that means there is no chances of that cultivation, and 1 means there is a positive chances, and 0 means that there will be no chances. Thank you so much. Is there any question? Is there any question?
Participants, if you wish to interact with madam, you can unmute yourself and you can interact, please.
Pardon, sir?
Yeah, I'm just
Hello?
requesting the participants to unmute themselves if they have any queries. That's what I'm asking. Participants, if you have any queries, please unmute yourself and you can interact with madam straight away.
Is there any query?
Good afternoon, ma'am.
Good afternoon.
I'm Lata from MAM College of Engineering. Ma'am, can you
Yes.
explain the sigmoid function once again, ma'am, please?
Yeah. Sigmoid function that have been used in the neural network actually. So this sigmoid function that have been used is in the logistic regression. The formula for evaluating the, the sigmoid function is 1 upon e raised to power minus x. The value that have been evaluated by using the sigmoid function is either 0 or 1. And when we plot the sigmoid function on the graph, it will be a, S-shaped curve. So since the value relies between 0 and 1, the midpoint that we have taken is 0.5. When the value that will be close to 1, we can say that the value is true. And if it is close to 0, that means the value is false.
Okay.
So on the binary classification, it can be a true negative, it can be a true positive, it can be a false negative, it can be a false positive. So when I have applied the logistic regression in the crop yield prediction, so first of all that I have to given the data by using the factor that I have used, and what will be the nitrogen, what will be the phosphorus, the soil, etc. And by using these, factors, we can evaluate which type of crop that will be better suitable for that particular land area.
Okay, ma'am.
This is what the sigmoid function that have been.
Thank you, ma'am.
Any other question? Any other question?
Participants, if you wish to interact with our madam, you can unmute yourself and you can interact, please.
Good afternoon, ma'am. I am Bhuvaneshwari Patil. I'm a faculty in Presidency University.
Yes.
Hello.
Hello. Yes, you are audible.
Okay, thank you, ma'am. Ma'am, my question is regarding measuring the performance of the model, ma'am. Like accuracy we have, F-square measure we have. Any other parameters by which we can measure the quality of the, the performance of the model?
Yes, there are so many parameters that have, yeah. There are so many parameters that have been used in order to evaluate the performance. I have taken, precision, recall, and F1 score. We can also use the for checking the accuracy, the confusion matrix, do the sensitivity. So these are the things that can be used in order to evaluate the accuracy. So this can be evaluated, or it can be implemented in Python if you want to evaluate in,
Thank you, ma'am.
Python language. So we have the classification report, confusion matrix, We can also use the t-test and, z-test also in order to find the accuracy.
Thank you, ma'am.
Question? Okay.
Sunil Garu?
So,
Yes, sir.
We can proceed.
Yes. Yeah. Thank you so much, ma'am, for giving your valuable insights in regression. I hope the participants are very much interested. That's why they have already interacted with their questions and all. Really, we are glad to have you as a resource person in this faculty development program, ma'am. So once again, from the Department of CSE, Sri Vishnu Engineering College for Women, Bhimavaram, We thank you, ma'am, for joining with us to share your valuable knowledge to our participants. Thank you so
sir.
much.
Thank you very much, madam.
Thank you, sir.
Have a nice day, madam. Thank you.